Hopefully you're feeling comfortable with the practice we just did using general probability. Now we're going to make things a bit more complicated. So now we're going to talk about the general addition rule. And unlike in the last section, we're not going to have everything perfect, disjoint, independent, etc. So now we're going to deal with items that are not disjoint. Remember, disjoint meant that it couldn't fall into more than one category. Because when it does fall into more than one category, it makes our calculations just a tiny bit more difficult, but it's still completely manageable. What we'll do quite often when we have things that are not disjoint is to draw a Venn diagram to help us visualize what's happening. For instance, here is a Venn diagram, and we have 100 people who are attending a play. 84 are from Omaha, 48 are men, and 40 are men from Omaha. I want to write everything as a probability, so if we have 100 people, obviously this is 0.48, this is 0.4, and then the rest are from Omaha, 0.84. Now, what you'll notice right away is, of course, if I add 0.84 and 0.48 and 0.40, that they add up to more than 1, which is not good because there's only 100 people. So we're going to switch everything to probabilities. We're going to fill out this Venn diagram together, and then we're going to be able to answer these questions. So first, I know that 84 people are from Omaha, 48 are men, and 40 are men from Omaha. Now, men from Omaha, typically you wouldn't have a label in here. But what I'm looking for is the intersection of people who are from Omaha and who are men. Well, that's 0.4. Notice I haven't put either of these in the equation yet. Now, I know that inside the men circle, it has to be all of the men, and there are 48 total men. Well, if there's 40% here, then this means that I have to take 0.48 minus the 0.4 that's over here, which means I get 0.08. So 8% are men who are not from Omaha. Does that make sense? So we started out with the 40%. This is the easiest one to do first if you have that value. 40% are men from Omaha. There are 48% men total, which means 8% go in men, plus the 40% over here, which means inside the circle for men is 48. Inside the circle for Omaha, I need 84. Well, I've got 0.4, so I need 0.84 minus 0.4, which would give me 0.44. So 44% are people from Omaha who are not men, which essentially means women from Omaha. Now what I'm going to do is I'm going to add these three values. So these three values are 0.44, 0.4, and 0.08. If I add all of these up, I get 0.92. Well, that means 92% are inside the circle, so these people out here, that would be the 0.08. Where did I get that? I took 1 minus 0.92 because I know total, everything inside the box needs to add up to 1. So again, here's my Venn diagram. And now, once I've done the Venn, these are easy. So the Venn diagram was the hard part. Then I can answer these questions fairly quickly because I have all of the values on here already. Question 1, the probability that someone is either from Omaha or a man. So what would I do? Either from Omaha or a man. I've got Omaha here, which is 0.44. I've got men from Omaha, which is 0.4, and I've got just men, which is 0.08. So I'm adding up all of those probabilities because that's men from Omaha, both men and from Omaha. 2, what's the probability that the attendee is a woman? Well, a woman would be someone who's not a man and not from Omaha, which is the 0.08. In addition, it would be people from Omaha who aren't in the overlapping men column. So that's the 0.44. So I would add those together. Now, some people don't love using a Venn diagram. They find it very confusing. So I'm going to show you, instead of the Venn, I'm going to show you the general addition rule, which we can use without having to make the Venn diagram. We can use it to answer these same questions. So here's the general addition rule. Before, when they were disjoint, we could just say the probability of A plus the probability of B. So add the probabilities together is essentially what we were doing before. Now we're looking at the fact that someone could be in both A category and B category. Now, if that is true, then that means I'm counting them as an A and I'm counting them in B, which means I have to subtract if they fell into both category because I added them here and I added them here, so I actually added them twice, so this is subtracting it once so that I have the correct amount. So again, using our last example, we had the first question, which is the probability that it was a person from Omaha or a man. So instead of creating that Venn diagram, I could say, well, 84% were from Omaha and 48% were men, and there are 40% who were men from Omaha. So I'm subtracting the intersection. I'm subtracting the people who were both Omaha and a man. So both of those things, and that gives me the 0.92. That should have been the same answer that I got previously. Here's one for us to try together. Again, you can do this without a Venn or with a Venn. I'm going to do both for you, just so you have the right idea. So we've got the pages of a textbook. 48% have some kind of data display in your stats book. 27% have an equation. 7% have both a data display and an equation. So what we're going to do first is make a Venn diagram. And of course I have it pre-made, but let's talk about how we did it. 7% had a data display and an equation. Notice I put 0.07. I did not put 0.7 because that would mean 70, so don't do that. So I have 0.07 in the middle. That's always the one that I place first. And again, it's the one at the intersection of data and equation. 27% have an equation, so I had to subtract this 0.7 to get 0.2, have only an equation with no data. Then we have 48% have some kind of data display. Well, I had to subtract this 0.07 because I've already counted it here to get 0.41. And then how did I get this number? I added up these three and subtracted from 1 because remember the sample space must be 1. So now I'm going to answer this question. What's the probability that a randomly selected sample page had neither a data display nor an equation? So here's data, here's both data and equation, here's equation. That was this number out here, is the 0.32. Next, what's the probability that a randomly selected sample page had a data display but no equation? So again, there are 48% with a data display. These are the data display, no equation people. Here's a question for you to try on your own using general addition rule. So press pause, try all of the parts, then press play to check your work. For this practice, I chose to do it without making a Venn diagram so that you could see just mathematically how you could reason through it without drawing the picture. So first, we know that 78% of drivers stopped on suspicion of drunk driving are given a breath test, 36% a blood test, and 22% both. First, what's the probability they're given a test? Well, the probability of test would be the 78% plus the 36%, which of course is more than 100. So this is where we would take breath plus blood and then subtract the probability that they're given both. So the 0.78, 0.36, and then subtract the 0.22 because I added those people twice. And that gives me 0.92. Next, a blood test or a breath test, but not both. So that would be breath union blood, just as we did before, minus the probability of both. So again, 0.92 minus 0.22. So keep in mind that this is a little bit different. I'm finding the probability that they had one or the other, and then I want to take out that middle section again where they had both tests. So here's the probability that they had either test and possibly both. Here's the 0.92 that I used before, and then I'm subtracting the people that would be in that center part of my Venn, which would be people who had both. People who had neither test, that would be 1 minus the probability that they had either, which is that 0.92. So 1 minus 0.92 gives me 0.08.